Welcome back to Maths with Mrs. V. Today we're going to continue with basic trigonometry and have a look at how we can do a few simple examples using the information about the trigonometry we've already learned. So you can look at my lesson 1 video to see those basics, and now we're going to apply that. So first thing we need to just remind ourselves of is what are the trigonometric ratios. So the three main ones that we deal with are sine, and then we normally use the angle theta, and that's going to be the opposite side of the triangle, depending on where theta is, over the hypotenuse. Then we have cos of theta, be the adjacent side over the hypotenuse, and tan theta will always be the opposite side over the adjacent side. Now these three trig ratios can be used in a right angle triangle. So I'm going to put an example of a right angle triangle here. And we're going to do some calculations with this triangle. So first thing, what we can do is we can actually work out what EF is. We can actually work out the length of EF because we have the two other sides. So in this question, we are going to first of all work out the length of EF. And we can do that by using the Theorem of Pythagoras. So we can say that because EF is the hypotenuse, it's EF squared equals 24 squared plus 10 squared. And then we can calculate that value. So the answer to that is 676 if you work it out on your calculator. And then of course we need to square root the answer because we're working out the length of the line. So that's going to be 26 centimeters. So we can pop that into our diagram. The next part of the question may ask you to work out the three trigonometric ratios for this triangle. So the first thing we need to do is our reference angle. We know that it's theta because it's been given. If the other angle is not labeled, that means that that's not going to be our reference angle, so we can ignore that one for now. And then we need to label the sides of the triangle according to the reference angle. So FD will be my opposite, ED will be my adjacent, and as always FE is opposite the right angle, so that is going to be the hypotenuse. All right, and then we can use the three trig ratio summaries that we did up at the top here for sine, cos, and tan, and we can actually go and just work them out by substituting in the values. So let's go and do that. So if the question was work out the three trig ratios, we can just go sine, my angle is theta, and it's going to be the opposite, which is going to be 10, over the hypotenuse, which is 26. So we can put that in, 10 over 26, and we always simplify these fractions for our final answer. And you can leave it as a fraction, you don't have to change it to decimal. Then let's go and do cos theta. So cos theta is going to be the adjacent side, which is 24, divided by the hypotenuse, which is 26. So 24 over 26, and we get 12 over 13. And then lastly we can do tan theta. So tan theta is going to be the opposite, which is going to be 10 centimeters, over the adjacent, which is 24 centimeters, so 10 over 24, and that's going to give me 5 over 12. And that's all we need to do. So if the question asks you to work out the three trig ratios, the first thing is to go and label the sides of your triangle, knowing that you have your reference angle given. After that, you can just go and substitute in the values for each of the corresponding sides that are relevant for that trigonometric ratio. Okay, let's try one more example. Now we're given two triangles and we're asked to work out cos of C, that would be cos of C, this being my reference angle. So that's another way that we can reference an angle. We can just put the angle sign on the name of the vertex. And then the other one is cos F. So we can work out cos of F. Okay, so let's start with C and work out cos C. So first thing we need to do is label the triangle with our labels. So we can see that the side AB here is going to be the opposite. Then BC is the adjacent. And AC is the hypotenuse. For the other triangle, we've got the opposite, hypotenuse, and adjacent. Okay, let's start with cos C. So we know that cos C is going to be the adjacent over the hypotenuse. If you need to, you can write SOHCAHTOA, so that you can check and you can see that cos is going to be adjacent over hypotenuse. So let's go and put in the values that we have. So the adjacent side is 24 centimeters and the hypotenuse is 30 centimeters. And we need to simplify that, which comes to 4/5. Okay, that one's done, so we can take that one off. Then we need to go and work out cos F. Now, the problem here is that we've been given the adjacent value is 16, and we need the hypotenuse to work out cos, but we haven't been given the hypotenuse, we've been given the opposite. So what we need to first do is actually work out the value of the hypotenuse, and we know that we can use Pythagoras' theorem to do that. So what we can do is we can say that df squared is equal to 16 squared plus 12 squared, and that gives us 400. Therefore, df is equal to 20 centimeters. And now we have the adjacent value, which we can use to calculate cos F. So we can go now and put cos F is equal to, adjacent is 16 over, now we've worked out the hypotenuse is 20, and if we simplify that we get 4 over 5. Now what's interesting about this scenario is that we actually end up with the same value that we did in the first place. So we have 4 over 5 for both of these. So this actually gives us some information about these two triangles. It actually means that the two angles that we were working with, C and F, are actually equal to each other. So we can conclude that the angle C is actually equal to the angle F. And because of that, we can look at the triangles and make a conclusion that these two triangles are in fact similar, because we can also say that angle B is equal to angle E. We know that they're both 90 degrees. And angle A is equal to angle D because that's the third angle in the triangle. Now we haven't been asked to prove this. It's just an observation at this stage. But this is where trigonometry becomes interesting, is because it doesn't actually matter what size the triangle is. If it's similar to another triangle, the trigonometric ratios that we work out will always be the same. So similar triangles have the same trigonometric ratios. So to summarize, if we are asked to work out the trigonometric ratios of a triangle, we need to first find the labels, and then we can substitute the values into the trig ratio that is being asked for. And sometimes we'll have to use Pythag in order to find any missing sides that are needed. Thank you for joining me, and I look forward to seeing you again. you.